Hello again. Well, we've done quite a few different projects on the shed, in the shed. We've got these sort of things where I bought a kit and built it up. But we've not really made anything from scratch really, so I thought in this video we'll do something a little bit different. There's many controllers that you can buy on the market. You've got small controllers, which is what's running this little matrix here. So this little controller here, these cost only about £3 or £4 from eBay, and they just got a load of patterns built in, and they just run by themselves. You can just plug it in and let it go. You've got other things like this, if you can open the box. So this is a little controller that you can use with an app, so you can plug it in and connect it to your Wi-Fi, and you can control LEDs using the app that you can download using the QR code. And you've got bigger ones like this. So this is a DMX decoder. You've got DMX in, DMX out, and you can control LEDs there. You've got different settings on the side here, speed, auto, because it's got some built-in modes as well. So that's another one that you can do. Or, there we go. Or you've got more professional things like this. This is a multi-output controller. This can run big sort of matrix displays like this one here, but a lot larger. You've got smaller ones here as well that can do different things. They all run on something called ATTiny. We're not really going to go into that at the moment, but just to show you, I mean, like I say, this is one here, look, a black one, simple one. This cost about £3. It's got a USB on it, and it connects to the LEDs. Nothing particularly complicated about those. You just literally, like we've got here, there's power going there, there's a controller there, and there's the LEDs there. You just plug them in and let them go. These are actually getting a bit warm because they're full brightness. So let me switch this off. There we go, and move it to one side. Here you can see we've got another strip of LEDs that are running at the moment with a pattern going over. So these are running actually off a 9-volt battery, running off this, and that's going through a little power converter here. That's going to convert the 9 volts down to 5 volts. And we've got this little circuit here. Now let me just zoom into this and so you can see it a bit clearer. Right, I've zoomed in so you can see, but this is a really small circuit board. It's got an ATTiny85 microprocessor on board, which is this little black square here. It's got micro USB in. It's got a small voltage regulator here, and it's got several inputs and outputs around the outside. So if we look on the reverse side, there's not much there, but you can see the connections. So we've got a couple of inputs or output pins there, depends how you program them. We've got a ground pin, we've got power in, 5 volts there, and we've got some more connectors here. And as you can see, I'm only using the 5 volts, the power in, the ground, and one of the pins just there. Actually, I'm only not even using that because the 5 volt pin, you can see I'm not actually connected, so I'm actually only using the voltage in pin for the plus 5 volts. So there's not much here, but what you can use these for is wearables. So if you want to put some LEDs on some clothing, this little tiny board is fantastic for doing that. And like I say, you don't need a massive battery pack. You can run it off a 9-volt battery. Okay, granted it's not going to last particularly long. It depends how long you want to run it for, but it does run on a 9-volt battery. This circuit board here again, you can buy these off eBay for a few quid. By the way, these little circuit boards, these little development boards, they start about £2 and go up to about £4.50 each on eBay, ridiculously cheap. So what this board does, it's what's called a buck step down DC to DC converter. So we've got 9 volts coming in and we've got 5 volts coming out, and we just connect that using these little connectors here to our LEDs and to power our circuit board, and we get a nice little pattern. Well, okay, I will say it's not difficult. What I mean by that is I must admit, I hate people who say, oh yeah, it's easy. Oh yeah, it's easy, all you got to do is this, this and this. Unless you've done it before, it isn't easy. But I will say is it's not difficult, and what I'm going to do in this video, I'm going to give you a step-by-step guide how to set one of these little circuits up, connect it to your laptop, program it, and what we might do is set up a hat. So I've got a hat here, and what I'm thinking of doing is wrapping the LEDs around this hat. So I'll show you how to do that as well, and see if we can set up this hat with LEDs, and so you can wear it at parties or something like that. So this is how it arrives when you buy one. It's just a plastic bag, one of these anti-static bags with the controller inside it. So let's open it up. There we go. It's about, like I said, it's about the same size as a 10p piece, something like that. Not particularly big. Let's scroll in a bit so you can see. There we go. The little controller's in the middle, and we've got contacts around the edges. So what we first of all need to do is to put some connectors on there. So we're going to use this connecting strip here. Where did I put my clippers? There they are. Right, let's just get a couple of these off. So for this little project, we need 3 of these. One for the plus 5 volts, one for the ground, and one for the signal. There we go, that's 3 of those. Let's put that to one side. So what we're going to do is to solder these on, and we're going to do it, we'll look at the back here, upside down, there we go, and the 5 volt is marked up just on the edge here. So what we need to do is to have something to hold this in place. I'm going to use this bit of foam I've got here, a bit of sponge. Here we go, 5 volts. Now the other thing is, this is plastic and it will melt, so we have to be quick with the soldering. There we go, let's put that in there like that. What can I do to hold that in place? There. There we go, I'll do it. Right, soldering iron. And the solder should be somewhere. There it is. And we'll just solder that pin onto there. There we go. Simple as that. That's one pin done. And the next one is next to it is the V in or voltage in. We're going to ignore that one. The one next to that is ground, so we're going to use that. Just the same thing, just pop it on there. That's a bit wonky, so let's do that again. Come on. Doesn't want to play ball for some reason. Let's just try that again. There we go, it's got it. Right, bit of a blob of solder, but it's fine, it'll do. And we're going to use P3 on the end here. That's going to be our signal out. So I'm just going to chop another one of these off. I have got one here, but it doesn't seem, I think it's a bit bent, that one, so I'm just going to get another one. That looks better. Right, I'm just going to use P3 on there. There we go. And we'll just solder that one in place as well. Great. So that's got those three done. So just to recap, what we've done is we've soldered onto the 5 volts, the ground and the P3. That's all we've done so far. Because we're going to eventually put the LEDs on the hat, what we're going to do is get the reel of LEDs. Now I'm using these WS2812b, they're 5 volt LEDs, and they come on these reels, so we're just going to pull all that off. There we go. And we're going to measure around the hat, so we're going to have it roughly towards the bottom there. And so it's going to be just there, and that's where the join is. So let's just chop that off. You see on the LEDs where there's a line. There we go. So you can see that line. That means there's a cut line there going across there. So let's just cut them off. There we go. Okay, so this is our LEDs. Now, and if we look at the LEDs, let's just see if we can zoom in on them a bit. Okay, let's see if we can get them in focus. Right, so if we look at these, you can see that you've got 5 volt plus there, you've got D there, and you've got ground there. That actually says DI, and that means data in. If we follow that across, you'll see we've got DO, which means data out. So this is the way that the data is flowing, and that's confirmed because here you can see arrows which point in the way that the data goes. So we know that the flow of information will be going that way across the LEDs. next thing we need to do is put some wires on these. So I've got this cable here. This is just 3-core cable. You can buy it on eBay. You've got red and white, which is the plus and the ground, and then the middle one is for the data. So we just pull those apart like that, and we'll just bare the ends like this. Just twist the wires round. And then we'll put a bit of flux on them. And then we need to put a drop of solder on. This is called tinning the wires, so we just need to tin them, just to cover the ends with solder. There we go. They're ready to be soldered up. So let's have a look at this. So we know that the arrows are showing which way the data goes. Let's just remind myself. Okay, so these are pointing that way, so the data is going that way. So we'll need to solder our wires onto this end. Now you may have noticed that the LEDs that I'm using have a cover on them. They're actually got a waterproof cover on them. It's a silicone cover on them. So you may think, well, what we've got to do, we've got to scratch off a bit of this silicone so we can solder on the pads. Well, not so, because what we can do, he says, is to flip it over. Now the underside of it's got some sticky tape on it. That comes as it is from the factory. But what we can do is, with our knife, we're just going to put the line across the sticky tape like that, and then we're going to gently just pull the sticky tape off. That, and you can see that we have pads underneath. I'm just going to scrape the pads as well. There we are. Now they're ready now for soldering. So before we do that, just the same as the wires, we'll tin them with the solder just to put a protection on there. So what I'll also do is, where's my little screwdriver disappear to? We'll just put a little bit of flux on there as well. Like so. Right, let's get the end of that tinned up. So let's make sure we get these right. So the ground is at the top, so that's closest to us now. So with our wire, the white is ground. And we can put that on there, like that. The middle is the data, so put that one on. And the one at the far end is the +5. There we go. So far, so good. Okay, next thing we need to do is connect one of these cables. Now we're going to be powering the LEDs through here, and we're also going to be powering the controller as well. So what I'm going to do first of all is just put a cable onto the signal wire, which is this one here. So we'll use this one here. Try and work out where his clippers are. There we go, at the end of the desk. Put a bit of flux on there. And we can solder them two together. So, twist them together like that. There we go, so they're now soldered together, and we'll put a bit of tape on there just to protect them for the time being. Now I know what you're thinking, we're going to put this on the hat yet, which is very true, and we'll have a look at how we do that later. But for the time being, let's just put that on there just to hold it in place. Okay, so let us now turn our attention to the microcontroller here. Let's just put the LEDs to one side. Now I'm going to assume a couple of things at this point. I'm going to assume that you know how to install and use the Arduino program, which we'll have a look at in a moment. I'm also going to assume that you know how to install things on your PC or laptop. What we need to do for the drivers for this little controller is to download the drivers for them. Now I'll put a link on this, so don't panic. There should be a link on the bottom of your screen now, and I'll put a link in the notes as well. And we're just going to go to this link here so we can download the drivers. Now I've already downloaded the drivers on my laptop, and the drivers are in this folder here, so let's open that folder up. And to install the drivers, you simply run the install program. And follow the wizard through. And there you go, it is that quick to install them, so that's fine. So we'll go into the Arduino interface next. Right, before we go any further, what I'm going to do is plug in the controller using the USB cable, and I'm going to plug it into the USB at the side of the laptop. Now what will happen is that the light will come on, which is in the corner here, and we're going to go to our Windows machine again, and we're going to right click on the Windows icon, and we're going to go up to Device Manager. Now in Device Manager you will see this here which says libUSB W32 USB devices, so we know that our device is installed correctly. Okay, so let's close that down, and we'll go into the Arduino interface next. There we go. Once we've in Arduino, we'll need to go into File, then into Preferences, and then into where it says Additional Board Manager and URLs. And there's a little icon at the end, so we press that. It gives us a box with where you can add in different boards. Now I've already added ours in, which is this one here, which will give us the correct boards that we're going to be using. Again, don't worry, I'll put a link in the description below, and there should be a link on your screen now. So we just type that in there, we press OK, and it will download any boards in the background that we need. It's absolutely fine. Next thing we need to do is go to Tools, and we go to Board, and what we need to do is to make sure we set it up for the right board. And if I can remember, sorry, it's the one that says DigiStump AVR boards, and we're going to set this for the default one, which is 16.5 megahertz, which is our little LilyPad board here. Once we've selected that, we can start writing some code. Because we're going to be controlling some LEDs, we need to have a library for the LEDs, and the one we use is called Fast LED. So let's go to Tools, like we've done before, and we go to Manage Libraries, and this will bring up a box with a whole list of libraries in it, and you can get libraries for all sorts of things. The good thing about the Arduino is that you can plug anything into it, and the amount of different controllers and things you get for them is amazing. So we type in Fast LED and press enter, and it'll bring up the Fast LED library for you. Now I've got the latest installed, but there are different versions, but just install the latest version, it's absolutely fine. I've already got it installed, but you'll have a little button down here, just like that, look, where it says install. So you'd have that down there for the Fast LED, and just click that to install it. Okay, once we've got that, I think we're just about ready to start coding. The thing I forgot to say was we need to add the boards in. So let's go to Tools, and we go to Boards Manager, and we type in the following, which is Digi Spark AVR, and that will bring us this package here, which is the DigiSpark drivers for the boards. You press install, let that install, which is what it's doing now. And then when we finish that, we press close. Right, so let's start writing some code. First of all, we need to do our definitions, so let's put that right at the top. We have to define what we're going to do, so the program knows what to do. First of all, we're going to include our Fast LED library. So like I said, I'm going to assume that you do know a bit about coding. So we need to include the Fast LED library. Give it some space to work with. Okay, let's do some definitions then. So first of all, our data pin is on pin number 3. And we're going to do the LED type. I think it's actually just WS2812. Yes, it is. There we go. And define the color order. And this is going to be GRB, green, red, blue. Next thing we need to do is a number of LEDs. I think there's about 37 or 40, but I'm going to set it to 40 for the time being. It's fine, it doesn't matter if it goes slightly over. Next thing that we need to do is to define the brightness. These are variables that we're going to use within the program. And we'll set that to 50, not too bright. Finally, the frames per second. And we set that to 120. So that's our definitions done. Now for fast LED, we need to tell it how many LEDs we got. So CRGB and a number of LEDs, which is going to be our variable. Right, so that's that bit done. So now we go into the setup, and we're going to, you've got two loops here, so you've got one loop and you've got one setup. When the program runs, it gets the definitions, it runs the setup once, and then it runs through the loop as many times as the chip is working. So it only runs this setup area once. So let's set that up first of all. What I'm going to do first of all is put a small delay in, just for 1 second. This just gives the program just a bit of a, the chip just a bit of a breather, just to reset right at the start. Now we need to set up the fast LED library with all the variables that we've set up at the top. So we're going to add the LEDs, and we're going to use the LED data type, or the LED type. Next thing we're going to do is tell it where the data pin is. So again, these are all the variables that we set at the top, and tell it what the colour order is. There we go. And a couple more things that we need to do. We need to tell it again that the LEDs, and a number of LEDs, right, so that's the fast LED library sorted out, and we can set the brightness. So fast LED, and we're going to set that to the brightness that we set up at the top. Which is 50. Now, the reason why I use variables within the code like that is that all you've got to do is, if you want to change it, you just change that number and it changes it throughout the code. So that's why we do that. Okay, so next thing we need to do, now the next bit is a bit weird because it's going to be in the middle of the two different loops here. So that's where it runs when it's sets up. This is what it's going to loop, but I'm going to give it a little bit of information here because we're going to use what's called a rainbow effect in a minute. I need to set up some information for the program here. So let's just do that now. This is going to set the hue or the color value just there. So we're just going to set that there. And there's a slight spelling mistake there. Let's just do that again. There we go. Now that's just a variable just to hold the start of the colours as a naught. So let's go into our main loop now. And because this is a loop, it's constantly refreshing all the time, going from the end to the start. So we're going to tell it, so fast LED show So that's going to show whatever values that we're going to add in a minute. You can put it at the end and you can put it at the beginning. It doesn't really matter. So what we're going to do now is 2 bits of code which we're going to show the library of the rainbow effect. So we're going to type in, so every, if we can spell it right, so every milliseconds, excuse me, and this is going to tell it to change the hue or change the colour, and the plus just means add one. It just means it's just a shorthand for adding one. Okay, and then we're going to say we're going to use a command called fill_rainbow, and we're going to use the LEDs, the number of LEDs, the current hue colour, and the 7 is just a tells the program what colours to use. If you want more information about that, I'll do a link as to what the fill rainbow procedure does, and so you can have a look at that. So next thing we need to do is check to make sure this is actually working. So we're going to use a button up here which is the verify. Oh, he wants us to save it first, so save it as rainbow, and you can see the bar here at the side, which is okay. So it's given us an error. So why is it giving us an error? Ah, okay. So it doesn't seem to like set brightness because I've probably spelt it wrong. Oh, is it because of the capital S perhaps? Oh, don't forget it's case sensitive, so I had a capital S, it's lowercase s. That's okay, let's try that again. Okay, that looks like it's going through. Let's see if it just finishes off. Yep, and that's worked okay. So the next thing we need to do is to plug it into or plug our board into the computer and upload the code. So let's do that next. Right, I flipped back to the laptop because it's easier to show you what's going on. However, what I can say is exactly the same code as I used on my PC, but I use my PC because it's easier to do the screenshots. Right, so we're now ready to upload it to the little controller. So I've got the USB cable unplugged at the moment, and the reason why you do that is you don't plug it in until it tells you to. So I'm going to zoom in at the bottom there, and hopefully you should be able to see. So I'm going to tell it to compile it now, and it does that by the upload button. Sorry about that. There we go. So we upload, and it compiles it, as you can see. So it's compiling just there, and the bar's going across just there as before, but we just have to wait. We don't have to do anything at the moment, and a message will pop up in a second telling us we're ready to plug in. This is in real time. I'm not fast forwarding this or anything like that, so we're just waiting for it to come up. There we go. Running plug-in device now, and it will time out within 60 seconds. So you've got to be fairly quick, and it will upload. There we go, it's done. Starting the upload, 100%. it's done, completed, thank you very much, it says. So that's it. So that code is now uploaded to the controller. So let's plug it into the USB, into the LEDs. Right, we're back on the bench again. Got a couple of wires here, so let's just clean these up like that. Like that. That's going to be our plus 5 volt and our ground. So let's just do the same with these. Now I'm not going to solder these up yet because we need to slightly change the way that we're going to power these shortly. But we're just going to do a little experiment to see if it's actually working or not. Right, that's got them two done. Just going to put a little bit of tape over the plus 5 volts so it doesn't short out. There we go. Right, so let's get our controller card here, and we're going to plug the 5 volts into the 5 volt pin, which is that one there. We're going to plug our ground into the ground pin. And we're going to plug our signal into the P3 pin. So that's those three in now, and we should be ready to plug in. Let's see if it works. So we have our USB brick here, plug it in, the light comes on, that's a good start. It's running the code. Let's see if it actually puts the LEDs on. There we go, LEDs are on. And you can see that the colour is changing as it runs along. And remember we did that hue +1, that plus, and that's what it's doing. It's actually changing the way that the LEDs are running. If you can see that all right. So that's that bit done. So far so good. So we've put the wires onto LEDs, we've put the wires onto the controller, we've programmed the controller, uploaded it and tested it. Now, I know I've done some breaks in there, but I can assure you that I haven't done anything extra. What you've seen is exactly what we do. So, next thing we need to do is to sort out the power and hopefully put it into the hat.